Hi everyone, Ali Raza here, and in this video we are going to start uh, programming in the assembly language. We are going to start from the very basics, and so in this video we are going to look at the basic instructions, some of them, and then the program structure. Alright, so this is what we are going to cover, which includes basic data types, the very basic ones, a typical structure of the assembly language program. Like in an assembly language program we have different sections, so we are going to look at them as well. And then the compilation process is simple, it's not too complex. And then we are going to go into an editor and then look at some of the basic assembly instructions and the building blocks. Alright, so before I move on to the basic data types, I want to discuss with you the structure of an assembly language program. So if you can see in this slide, you will note that we have written data section, text section, BSS and RO data. What do we mean by that? So when we say data section, so typically what happens is that in an assembly language program you have different sections, and each section has its own purpose. And so what happens is that in most of the assembly language programs, and even in different flavors, the data section is where you place your initialized data and like variables, stuff like that. So this is where the data section comes into play. And then you have the text section. So the text section is equivalent to the section where you put all of your code. So let's say you have a main function, and that main function will actually come into the text section. So text section is where you have the executable code, the code that is going to be executed. And then you have these two sections. The one is BSS. BSS is mostly used for uninitialized data. So think of it as variables that you have just declared, but they are not initialized. And similarly we have the RO data. RO data stands for read-only data. So if you have, for example, in a high-level language like C or C++, if you have written a const in front of a variable, so you are saying that okay, this thing is read-only, you cannot modify it. And so if you think of it as something that is not modifiable, then that will go into the RO data section in an assembly language program. This is the typical structure. There are many more sections, and so if you try to explore them, like look up on the internet, you will find that there are more than 4 sections. There are a lot of them, and each one has its own purpose. But for most of the time you are going to be dealing with these, if not just the first two, not even the BSS or our data. But yeah, these 4 are the main important ones. Alright, so now we can move on to the basic data types. So in an assembly language, you don't have complex data types like you have in the high level language. For example, in C language or C++, you might have a character, you might have string, you might have let's say vectors, like all these complex types. But when you come or go down at a lower level, here for example in assembly language, you do not have that kind of complexity. So they are like simple building blocks, simple data types. And so if we look at the basic data types, we have everything with regards to the bits and bytes. So assembly language is all about bits and bytes and dealing with bits and bytes. So starting from the very first, we have a byte, and as we know that a byte is 8 bits. So if we convert or like change the unit, that would mean 1 byte. So 8 bits 1 byte. And I have also written the directive. Now what do we mean by directive? Directive is just a way to specify the data type. And so I have only written here for NASM and MASM. There is also another one called FASM and GAS, but most of the time you will see people using NASM or MASM because These are famous. These are the mostly used. MASM is mostly used in Visual Studio, also on Windows, and you will see NASM being used on Linux and Windows, so in all major operating systems. So a byte is 8 bits, 1 byte, and then the directive for NASM is db, defined byte. For MASM, it's byte. And so if we go down, we'll see word, and a word is 16 bits or 2 bytes. And for NASM, it's defined word, and for MASM, it's word. So for the data type, you will see that MASM has the exact same uh, thing to actually define the data type. So while NASM has this defined byte, defined word, and then so on. And then we have double word, quad word, and 10 bytes. Double word is 32 bits, and then quad word is 64 bits. And for their directives are dd, dq, and then for 10 bytes, which is a t byte in MASM, and then dt in NASM. Its size is 80 bits or 10 bytes. Alright, so I told you about different sections, and so this is actually a typical structure of a NASM program. Now for MASM, it may be a little different in a sense that you may not be writing section, you might just be writing dot data or dot text. But when you are working in NASM you have to do it like this. So for example, if you want to uh, start a section, you just say section, and then for example, we are starting the data section, we just say section dot data, and then we are starting the text section, we just say section dot text. And in this way things are in the NASM. In MASM they are a little different, but for the most part uh, you will not have any problem if you switch from either of them. Alright, so I also have written some comments here, but they are just for your own understanding. Do not worry about them too much. Alright, so when it comes to the compilation process, it is actually broken down into two major steps. So first off, we are assuming that we have been provided with the assembly code. We have the ASM file. So now what we do, we take the ASM file and we first convert it to an object file, and then we link that object file to actually create the executable. So when we say we want to convert the assembly code into an object file, what we are doing is, for example, if you are using NASM, these are the commands that I've written here for the Linux and Windows. So for example, let's say you are on 32-bit Linux. So what you will do is you will have the ASM file, the assembly language file. You will say NASM, and then the architecture you will describe it. So here it's ELF32, as we know that for 32-bit in Linux the binary file is an ELF, has an structure of ELF. So we will say ELF32. We will then provide it the file, let's say sample ASM, and in return we would want it to give us an object file, which we will also name it. So here for example it is sample.o. And then once we have the object file, we actually take it to LD. Now LD is not pre-installed into the system, so what you do is it's called a GNU linker. So when you're installing the C or C++ compiler, I believe that most of the time it comes with it, or maybe you have to install it separately, but you might look on the internet about the GNU linker, and then try to follow the instructions there to install it on your system, whether it's Linux or Windows. And then once you have it, what we do is that in order to create an executable, we have to specify the architecture. So if you are on Linux 32-bit, we will say LD, and then pass it the architecture, which in this case is ELF underscore i386. And then we'll say, okay, we are giving you this object file, and you can produce for us an executable file. And it's in this way we have the compilation process. This is a typical compilation process that is broken down into two steps. And so now let's look at the basic assembly instructions. And so I have written here four of them. The first one is move, add, sub, and inc. And so what do we mean by these? So in assembly language, things are very primitive. And when we say primitive, we mean that we are working at the lowest level, not the lowest, but I would say second lowest. And so when we are thinking in terms of like low level, we are then thinking about moving data from one place to another, and so on. And so in assembly language, the move instruction is used to move things from one place to another. Now those things might be in memory, those things might be in registers. And so when we use the move instruction in assembly, what we are essentially saying to the assembly language is that, okay, now I want to move this thing from that, and so on. And similarly, we have the add is simply adding things. So let's say you have two registers, and so you want to add the value of one register to another. You will simply use the add instruction. And similarly, we have sub, which is for subtraction, and then inc, which is simply increment. So if you want to, let's say you have a register and then you want to increment the value of the register, you will simply use this instruction. And so now I want to show you it in terms of code. And so what we will do now is, first I will show you the IDE that we are going to use. So for this we will try to keep things simple. And so if you want to try to keep things simple, we will go ahead and use how should I pronounce it, SASM. I hope I'm pronouncing it right. And so this is an IDE which supports NASM, MASM, GAS, and FASM. And it also has a beautiful syntax highlighting and a debugger as well. These things are very handy because now you don't have to worry about the compilation process, although we are using this because we want to make things simple. But you can also, just go ahead and use a simple text editor and then do the compilation process by yourself. At the end of the day, you're going to get the same result. Okay, so if you go to this site here, or type on Google SASM and then download it. So once you have it downloaded, what you will do is you will open it. And so once you open it, you can create a new file, and which will have a different structure, not exactly this, something else. So you can remove it, and so once you remove it, it will be a clean file. And so now I will try to show you the instructions that we have seen in the slides. So as we know that data section is used for the initialized data, I believe. Let me put the previous code, right? And also for like like storing the variables which are initialized. So this is like a simple thing. It might be something else, but in a nutshell this is. And then once we have the text section, and again this is for NASM. For MASM it might be a little different. You might not be doing this, you might be saying like dot code or something else, but for NASM you have to say text. And what happens is that if you are on Linux, what you will do is you might say global start. Now what we are saying is that this is a procedure start, and this is where we are going to start. This is what you do in Linux when you are on Linux. But if you are on Windows, you don't say underscore start, you say global main. And so in this way you define the procedure, and then you give this is the label. The main is the label. And so what we do after main is everything is our executable code. So whatever we want to execute, we will just write it here. So now let's look at the first instruction, which is the move instruction. Is used to move things or data from one place to another, right? And so if I say move and then I specify the should I say destination, and then source, right? And so this is for the, I believe it's for the Intel syntax. and so for AT&T syntax things might be a little different. So in the AT&T syntax, you have these like percentage signs and stuff like that, and so it might differ a little bit, but at the end of the day things are relatively same. And so if you learn one syntax, you will not have any issues with the other syntax. So things might be should I say reversed. So because we are here at the Intel syntax, we are saying destination and then source, but if we are in the AT&T, you might have source and then destination. So that these are some differences between these two, Intel and the AT&T syntax. But you don't need to worry, because if you learn either of them, you just need to do minor changes and that's it. Things will start working. Alright, so let's say we want to move some value into one of the registers. So we have studied about registers in our, I believe, in our first lecture. And so let's say I want to move the value 10 into the register EAX. And so what it will do is it will say, okay, this is the destination and this is the source. Move will do what? It will just say, okay, take this 10 and then move it here into the register, or anything that we have specified, although there are restrictions. For example, you cannot move one memory location to another memory location, uh, but you can move registers to memory location, and for example memory location to register. So there are some restrictions that you have to keep in mind, and as you go along, as you program, you will automatically remember them. Alright, so let's say move EAX10 and then move EBX20. Alright, and then we have these. So let's say I say move ECX30. Now I'm not going to run it, because this is as of now this is not a valid program, but what we can do is we can actually debug it. So I will show you the debugging part, and hopefully it will give you a more clear idea of as to what's happening. So if we look at it now, don't worry about this line, this was added by the SASM itself for correct debugging. And so if I say EAX10, so let me say step into, so just focus here, EAX, and then this line, right? So right now it's 0x1, the EAX register has a value of 1, and so if I say step into, you will note that now it contains 10. The EAX register now has a value of 10. This is what move does. It actually moves values, things from one place to another. And so similarly, if I run this line, you will see that EBX now has the value of 20, and similarly if we run this line, it will have the value of 30 as well. And so this was the move instruction. Now let's quickly go through the rest of the instruction: add, subtract, and increment. So let's say add instruction, I say move EAX10 and then add EBX EAX. So what we are saying is whatever is in the EAX, add it into the EBX. And so I will say add ECX EBX, and so if I try to debug it now, so let's move, move, and so it says move EAX10. So the EAX already had the value of 10, it will have the same value. We will say add EBX EAX. So EAX is done, and then EBX is 20, so I believe it should be 30. So as you can see, EBX now has 0x1e in hex and then 30 in decimal. And so similarly, if I run this line, it will give us the addition of EBX being added into the EDX. So what I will do is I will simply add this line. Don't worry about this. I'm just adding it so that the program doesn't crash. So let's say we have this add instruction, and then we have the add instruction executed. So EBX should contain 30, and now ECX, what value ECX has? 30. So if you run it, you can see that ECX now is 60. So 0x3c 60, and so in this way uh, the add instruction works. And similarly, if we try sub instruction, we can say uh, let's say move EAX 5, move EBX 5, right? And then I will say sub EAX 3, right? And so if I debug it, if we start to debug it, we will go there, and then we will see that EAX now is 5, EBX now is 5. And then if I say sub EAX 3, and so you can see that it has the value of 2, so it subtracted the value from the register itself. And so similarly we can have the increment instruction. So increment instruction actually works on a single register. You don't have two like a source and destination. You just have the register or something that you want to increment. So let's say if I say inc instruction, so I can say move EAX 1 and then inc EAX. So if we try to debug it, you will see that EAX is 1, and then we are about to execute this one. If you focus here, you will see that it now became 2, so it incremented. And so we can move here, and in this way these 4 basic assembly instructions work, right? And so we will start diving deeper. We will look at more instruction, we will look at more semantics and syntax, everything. So yeah, this was about the basic instructions, and I hope you understood a little bit of it. If you did, then yeah, we have accomplished our goal. And so I will see you in the next video. Until then, have a good day.